Hello, everyone. I am very excited to introduce our next speaker, Katie. I would like to start by remarking their significant contributions to the Python community. Ka- Katie has served as a director of Python and Django Software Foundation and also the core organizer of PyCon Australia, PyConline, while being a serial keynote speaker at PyCon Australia, PyCon Taiwan, PyCon Thailand, and now at PyLadiesCon. Today, Katie will be sharing insight of turning what into why. Please join me in welcoming Katie to the stream.
Aw, it's such a great introduction. Okay. I've got to follow that up with a good keynote. All right. Can I please have my slides? Wonderful magic man. Hello. I have slides. I will now start my timer. And thank you for letting me talk at PyLadiesCon, a conference about Python and ladies. Let's talk about JavaScript. In JavaScript, what is 4 plus 2? Sorry, I can't hear the online audience, so I'm going to presume that there are many people saying 6. You're right, it's 6. So what is 4 minus 2? Well, it's 2. So what is 4 minus the string 2? It's 2. So of course 4 plus the string 2 is 42. Let's talk about JavaScript. In JavaScript, is 1 equal to the string 1? Well, yes. In JavaScript, is 1 actually equal to the string 1? Well, no. Let's talk about JavaScript. In JavaScript, what is the sum of 2 empty arrays? It's an empty string. What is the sum of an empty array and an empty object? It's the string object. What about the sum of an empty object and an empty array? It's 0. And what about the sum of 2 empty objects? It's of course not a number. What? For those of you who remember a 4-minute programming talk from well over a decade now, you will recognize this as one of the examples that Gary Bernhardt did in his WAT talk. In this talk, he discusses some of the eccentricities of Ruby and JavaScript, but focuses only on the WAT, literally ending each example by saying WAT. But this isn't a WAT talk. This is instead a why talk. We're going to learn about some of these strange edge cases in programming languages and then dive into why they may not be strangenesses at all, but a misunderstanding of implementation details, a common foot gun, or something else. So let's start with JavaScript. In this first example, it's an issue of overlaid operators. In the first one, we have implicit coercion. Subtraction is only defined for numerics. So in the first example, we're coercing the string into a number and then performing the operation. In the second, the plus is an overloaded operator. It acts as both numeric addition, or in this case, string concatenation. In our second example, we have the case of 2 different equality checks with different strictnesses. In JavaScript, double equals will only compare values after they have been coerced into the same type. But triple equals will also confirm that the types are equal, which in this case they're not, so it returns false. And in our third case, it's a little bit more complicated because we still have that overlaid operator, but it's a little bit more complex. So to explain this, we're going to need to dive deeper into the addition operator in JavaScript. What does it do exactly? Well, thankfully, we have a way to know exactly how it works in JavaScript by looking at the ECMAScript 2023 language specification as defined by ECMA 262. This is the standard that defines the JavaScript that you use today in your browser. And this specification also covers JScript and ActionScript. And within this standard, we can go to section 13.8.1, which details requirements for the addition operator. Immediately a note, the addition operator either performs string concatenation or numeric addition. Keep going down and we see runtime semantics, which says to use the evaluate string or numeric binary expression function, which if we go there, says to use the apply string or numeric binary operator, which if we go into there, makes everything perfectly clear. Many language standards read like this. You do not have to know how to read this just by me showing it. It is useful if you want to implement JavaScript. It is not useful if you want to learn how JavaScript works because you first need to learn how to read language specifications. So let's do that. What I'm going to do is step through this apply string or numeric binary operator in a way that's a little bit simplified for the purposes of working out what's going on with our previous examples. So, step one, as per this specification, we need to convert both sides of our equation, so a plus b, we need to convert both into primitives. Then the specification says if either a or b are a string, then return the string concatenation of both. If we're still going, we then need to convert both a and b to numerics, then return the operation on a and b, in this case, add them together. The two primitive is described elsewhere as the following methodology. If a is an object, then let the result be the value of a, and if that is not an object, return the result of value of. Otherwise, if we're still going, return the result of toString of a. And if that's not an object, then return the result. Otherwise, if a is not an object, just return it. So this is a way to simplify down more complicated things in JavaScript. You may have seen where this is going. Let's consider one of our examples, the empty array and the empty object addition. So, according to our algorithm, we first need to convert both sides to primitives. To do that, we can use type of. What is the type of an empty array? It is an object. But we know that the value of that is probably not going to be what we're expecting. It's going to be the value of an empty list is going to be the object itself. So what we need to do is convert that to a string, which is where we get one of our first culprits, the empty string. How does that work then? Well, the array object has an internal method defined for this, which says array prototype toString is to return a call of all the elements of A. So for an array of 1, 2, 3 join, it would be 1, 2, 3. And for an empty array, it'll be an empty string. So what about the other side? What about our object? First, we need to check the type of this object. The type of the object is an object, and the value of that is our empty object. So we now need to cast it to a string, which gives us the string object. How does this happen? Well, again, this is defined. As part of objects implementation, the toString says use internal methods to determine a tag and then return the string object tag. In JavaScript, anytime you try to get the output of any complex object, similar to a dictionary in Python, you will always get the string object. A lot of programming languages have a type of method like this where you want to get the stringification of an object, return a string based on the representation of the contents of the object. In JavaScript, it helpfully tells you that it is an object. If you want to get the stringy representation of an object in JavaScript, you can use json.stringify, which will get you something similar to what you would expect from a Python background. So we know what our empty array is in a primitive, and we know what our empty object is in a primitive. Great. So we can have our empty string and our object. We can concatenate those two together because they're both strings, and we get object. So now we have our primitives. We can replace them for our other examples. So two empty arrays is going to be the concatenation of two empty strings, which is going to be the empty string. But in our other examples, when we're leading with the object, it gets a little bit more complicated because mathematics describes that addition should be commutative. The result of a plus b should be the same as b plus a, but in our example, it isn't. But guess what? This is also defined in the specifications. I know. In this section about runtime semantics, it specifically defines that the block of curly braces should return empty. So what's actually happening here is that JavaScript is seeing the empty object on its own as undefined. So if you prefix that to an addition, you're actually trying to do a nothing plus an object, which in this case is defined as a unary operator, specifically saying that if you only have the plus and a thing to cast that to a number, in this case, we know that the primitive of our empty list is an empty string, and we cast that to a number which is 0. So that is also defined in the string numeric value where if it's 0, it returns 0. White space is always 0. It's all defined. It's all in the specs. It's fun. Specs are great. But what's happening with our two empty objects? We know the first result is empty, and we also know the second result is the string object. But now we also know that that is a unary operator, which tries to cast that first character as a number, which is not a number. So that's basically our solution here, except I was cheating a little bit because in my examples earlier, I explicitly said that we need to get the value of our empty object. So I was actually putting parentheses in there, which is how you would solve for this. Because if we don't put the parentheses in, we get 4 distinct different results. But if we put the brackets where it should be, we at least get a plus b being the same as b plus a. So we did it! Hooray! And now I hear you cry from your many bedrooms and watch parties. Isn't JavaScript awful? It's just the worst. Well, I would hope that if you listen to the last 10 minutes, you might understand that at least why one of these popular WATs is the way it is. JavaScript isn't awful or the worst, it's just the way it is. I could go into the history of JavaScript, illuminating more about the rapid development that JavaScript underwent, the relationship between JavaScript, web browsers, and universal backwards compatibility. Or, instead, I could say, guess what? It's not just JavaScript. I have about 28 minutes left before I'm going to get kicked off this live stream. Let's start with Python. In Python, if I declare variable a as 256 and the variable b as 256, is a equal to b? Yes. Let's talk about Python. In Python, if I declare a as 257 and b as 257, is a b? No. But if I declare both variables on the same line and check, they are. Let's talk about Python. In Python, when you load Python in your command line, you're probably going to be loading CPython. And an optimization of CPython is to create a list of integers from -5 to 256 for you in memory. When you assign a variable, it can point to a part in memory that it prepared earlier. So when we declare a and b as 256, we're going to be pointing to the same part of memory. So if we ask for the identity of these two objects, the is, we are checking, are these the same object? Because both variables are pointing to the same part of memory, they are the same. But if we declare the variables outside of this integer cache, we're assigning these variables to two different parts of memory, and so they are not identically the same object. But if we declare them both on the same line, an optimization allows for the allocation of the same part of memory, so these are the same object. Now, with all these examples today, I'm going to be describing how to avoid this. In this case, instead of using is to check if two objects are equal, use an equality check. If you want to check for equality, use equality. You probably don't want to be using an identity check in most cases. Let's talk about Java. In Java, if I declare an integer a as 127 and b as 127, is a equal to b? Yes. In Java, if I declare the integer a as 128 and b as 128, is a b? No. When you're running in Java, you're probably going to be running something like OpenJDK, and the OpenJDK implementation is open source. So I can see exactly the implementation of Java here, because we can see that in OpenJDK, the integer cache is defined from -128 to 127. So we have the exact same thing as going on with Python, except in a different range. Also, when you call a double equals on two integers, you're actually doing an identity check. So we're going to get the same issue as in Python, just for a different range. So to avoid this, you want to actually be using dot equals when you want to check equality in capital I integers, or drop down into the primitive int type and then use double equals to check for equality. All these things might be seen as quirks at first, but if you have a deep understanding of how the language works, it's not a quirk, it's how the language works, or more specifically, how it's implemented. Let's talk about Perl. In Perl, if we want to check if the string A is equal to the string B, in this case, our sample will print the string match if they're the same and do nothing if they're not. So of course we know that A is equal to the string B. I mean, of course they do. Why wouldn't they? That's because the double equals in Perl checks for numeric equality, where both sides of the equation are explicitly cast into numerics first and then compared. And in this case, both the string A and the string B numerically are 0, and 0 equals 0. If you want to be checking for string equality in Perl, you should use EQ. Let's talk about bash. In bash, if I want to check whether two values are the same, I can do what's known as a conditional here. So I'm saying if A is equal to B, then echo match. Similar implementation to what Perl does. So of course we know that the string A is definitely equal to the string B, and so they match. Because in bash, EQ are arithmetic binary operations. So both sides are being cast into numbers and then compared, and A and B as strings are the same number, which is 0. So if you want to be doing string equality in bash, you have to do double equals. Programming languages have a reason, a rationale, a description of what they do and why. Depending where you are in learning a new programming language, you might be a textbook person, but no matter how strong your proficiency is, you may always find yourself reaching for reference material. Whether it's a manual, a textbook, a forum, or a friend, you do not have to memorize the entire thing, because if you're doing different languages, things act differently in different languages. That double equals keeps on showing up. Even if you know the common things to watch out for in your primary language of choice, there's often going to be something that trips you up. Let's talk about Python 2. In Python 2, we know that 4 is less than 2, right? No, of course no. 4 is bigger than 2. Even Python 2 knows that 4 is superior. And we can prove that by checking if 4 is greater than 2, which of course it is. But is 4 bigger than the string 2? No. So the string 4 is larger than 2, right? Well, yes, okay, this is fine. But let's keep this going. Is 4 less than the string 4? Yes. Is it also less than... Sorry, is 4 less than the list 4? Yes. Is it also less than the string 4? Yes. Is it also less than the tuple 4? Yes. Python 2.7 defines comparisons thusly. Objects of different types, except different numeric types and different string types, never compare equal. Such objects are ordered consistently but arbitrarily, so that sorting a heterogeneous array yields a consistent result. See Python implementation detail. Objects of different types except numbers are ordered by their type names. We are ordering integer, list, string, tuple. I think I don't have to tell you that the way to avoid this one is just to avoid Python 2. Use Python 3. Python 3 is great. It supports emoji, and it does things like Unicode, and it's actually supported, and it gets security updates. You should be using Python 3. Python 3 is great. But also, if you try to do the same thing in Python 3, it'll give you a type error saying you cannot compare different types. It's great. You should use Python 3. This has been your 5-year ongoing PSA to never use Python 2 anymore. Okay, let's talk about PHP. In PHP, we can use a ternary operator to ask if 0 is equal to the string match, question mark, which is our ternary. If it's true, do the thing on the left of the colon. If it's false, do the thing on the right. So in this case, we want to echo true if it's true and false if it's false. So what is this going to print? It depends. If you're running PHP 7, this will be true. If you're running PHP 8, this will be false. PHP has undergone some major changes with its major versions over the years. The work required to get Unicode working in PHP was so vast and even abandoned at one stage, where PHP 6 was never officially released, and instead the official version skipped over from 5 to 7. And in PHP 8, there were more breaking changes, like changes to string comparisons. Previously, it would always cast the string to a number and then do numeric comparison. So in the first case, it would cast match to a number, which is 0, and then 0 equals 0. However, PHP chooses now to do the type check first. So if it's a numeric string, it will do a numeric comparison. Defined elsewhere, that is the string that emotes a number using digits, decimal places, and well-defined scientific notation. Otherwise, it converts the number to a string. So instead of casting match to a number, it's casting 0 to the string 0, which isn't the same as the string match. And this comes up in some very, very minor differences between how loose comparisons with double equal works between PHP 7 and 8. Hopefully you won't specifically encounter this because you're not using loose comparisons, you're using triple equals. Yes, PHP also has triple equals. And unfortunately, if you are using PHP, there was going to be a compiler warning about this that never made it into 7.4, so you're going to have to manually check for this. But as a general rule of thumb, always use strict equality comparison operators when provided by your language. This slide makes complete sense in context. Programming languages can have deprecations. Languages can adapt and evolve to changes, and major versions are allowed to have major changes that sometimes break things. I know. There are community-defined support standards for older versions, but when releases happen, they'll have new features as well as deprecations and stronger community support than the older versions. Update when you can. Let's talk about Elixir. In Elixir, if I want to map over a range of 1 to 5, where each number I want to square it, I get a list of the first 5 square numbers, 1, 4, 9, 16, 25. Cool. And if I do the exact same thing for instead of 1 to 5, I want to do the range of 6 to 10, I get a very upset computer that I think wants to swear at me. Let's talk about Elixir. If in Elixir, I wanted to instead save the result of this mapping into a variable, and then I want to use io.puts, which is similar to print the result, I would get the squared numbers that I would expect. So why did our first example break, but this one doesn't? Let's try a different range, just something random. Let's say 65 to 90. And let's not do anything. Let's just return the result. No particular reason, but if we run this, we get a very recognizable string. In 8-bit character encoding ASCII, capital A starts at sequence 65 of an available 255 characters. ASCII is really cool like this. What is happening is that Elixir was built on top of Erlang. Erlang dates back to the mid-80s, and in many languages, strings are just a list of characters. But in Erlang, strings are a list of integers representing ASCII character code points. So in Elixir, if it sees a bunch of numbers that looks like it's within the range of printable ASCII characters, it will presume you mean a string. This is something that mostly happens if you're using the command line interpreter, because like in Python, if you're familiar with IPython, you can just put in a variable, it'll return the thing, but in executable programs, you'll be using print or system out or some other thing to actually print the result. And in Elixir, we can see that if we explicitly use io.puts, we get the exact results we expect. I guess the lesson from this one is your code will run different in an interpreter than when you execute it elsewhere, I think. Cool. Let's talk about C. We've experienced a lot of WATs today, so let's make a short program called WAT, where it just prints WAT. And if we compile this and then we execute it, instead of WAT exclamation point, we get WAT pipe. I first encountered this many years ago while trying to debug something by literally typing this. This is probably where the name of this talk originated. Because I lied a little bit. Actually, in current C, you have to compile the program using the trigraphs flag, which will show up with this error. Now, obviously, this just means that C doesn't understand millennial speak, right? Because it doesn't. C predates ASCII. C was designed around the character encoding ISO 646, which was also standardized in ECMA 6, which I cannot find a digital version of scouring the internet to prepare this talk, but instead I give you the vintage scans from 1973. The first edition of this standard dates back to 1965, which is far too long ago, and even the ECMA publications portal doesn't have a digital scanned version of the first edition available at the time that I was preparing this talk. This is the earliest available version I could find. Just look at that typesetting. Oh, it's even got ring bindings. Whoa. The standard defines the basic code table, which itself has little footnotes markers around the code points for hash and dollar mark, etc. And ECMA 6 is only a 7-bit encoding set. When while it gives it a red hot go, it just only so many characters that it can have available. And so C explicitly includes the ability to add 9 trigraph sequences, tri meaning 3, graph meaning graph. So 3 character points to denote characters that wouldn't otherwise be available. And so you can see here that our question mark, exclamation mark is our pipe character, and so you can see where this mapping is happening. But C is still evolving and has a new standard being developed at the time of writing this talk, where trigraphs will be removed as of the next release, C23. And the document that proposes this removal just tickles me because it's literally called Remove Trigraphs. I can't even say that title without sounding like a clickbaiter. Let's talk about PowerShell. In PowerShell, if I were to say, is 63 larger than 42, I want to return true. Otherwise, I want to return false. And of course, I get false because PowerShell understands numerics and it understands that 36 is not bigger than 42. Math, it still works. So if I change the direction of the comparison operator, I should now get true, right? If this was a live talk, there would be a whole bunch of different cacophonous noises. Because PowerShell is a combination compiler and interpreter. It has operators similar to Bash, but it also is a rich programming language in and of itself. In this case, greater than the symbol is actually file redirection, which saved the file to disk named 42 with the contents of 36. In this case, the file redirection operation was successful, but it returned no value, and a no value is falsy, so the false side of the conditional was invoked. And the PowerShell documentation says the greater than operator isn't to be confused with the greater than comparison operator, often denoted as the alligator in other languages. It then shows an example. It shows our example. Because the PowerShell documentation is open source, and I got this example added to the documentation. This was a few years ago, but I'm still proud about it. The way to get around this one, use actual comparison operators. Yeah, they exist, just dash GT and dash LT, and it also means you don't have to remember which way the crocodile goes. We've discussed several programming languages, each of which can be described as a WAT. But if you have a deep understanding of how the language works, it's not a WAT, it's how the language works. Programming languages predate the first time humans poisoned sand and tricked it to do math for us. No, really, Fortran was first developed before the creation of the Silicon Integrated Circuit. It ran on mainframes that used vacuum tubes. There are many dialects that you can use to make machines do your bidding. The notation is vast, and the symphonies you can compose are many, but you need to know how to play the instrument you have. Whenever you find yourself thinking WAT, turn it into a Y. Find out why things are the way they are. Understand the reasoning behind the decision. It will help you get a deeper mastery of the language, and you might just learn something new along the way because, hey, we're at the end of the talk, right? Most of these examples happen to me. I've been a software developer for closer than 2 decades that I'd care to admit, And if you've read my bio, I've worked in many different programming languages. And when I was earlier in my career, I would be that guy who would say, why would I use Python when I have Ruby? Ruby has all these cool things like flip-flop operators. I code in Haskell now. Why would you use a duck type language? Types are cool. But in the end of the day, they're tools. They're tools used to manipulate data to solve problems, and each of them has their time and place. I've learned so much from all the different languages that I've used, and I now know how to take a look into the deeper understanding of how a programming language works before I cast judgment. So if you're only proficient in one programming language, that's great. Do that. But why not try your hand at something else? You might learn something new and deepen your understanding of how your primary programming works along the way. All the resources for today's presentation are available at glasm.com/WAT, including the ability to replicate all the examples that I've shown today. Thank you so much for your time. I have a duck that looks like the WAT duck. And that is the end of my keynote.
Thank you, Katie, for the amazing keynote. I just love it. Thank you for being here today. And if you have questions for Katie, leave them on Discord. Thank you very much again.
Quack.